A mountain in southwestern British Columbia is actively dissolving itself from the inside out. Not by erosion, not by mining, but by its own internal heat and chemistry. As of this year, the Mount Meager massif, the highest volcanic threat in Canada, is being systematically weakened into unstable clay. Its glaciers, the very ice that has held its fractured peaks together for centuries, are now in retreat. And deep beneath that ice, toxic volcanic gas is venting into the atmosphere through newly formed caverns. This is not the story of an impending eruption in the way we typically imagine one. It is the story of a catastrophic structural failure unfolding in slow motion just 150 kilometers from Vancouver. And the most alarming part is not that this volcano is waking up. It is the evidence that suggests the first disaster will not come from an explosion of magma, but from the simple, terrifying force of gravity acting on a mountain that is turning to dust. To understand the scale of what is happening, you have to go back to July 21st, 2016. A helicopter was making a routine flight over the remote Pacific ranges, carrying biologists contracted to perform a summer goat count. As the pilot passed the western flank of Plinth Peak, Meager's highest summit at 2,680 meters, he saw something that did not belong. 3 enormous, perfectly circular holes had melted through the ice of the Job Glacier. They were dark, cavernous, and visibly steaming. This was not a crevasse or a seasonal melt pool. This was something else entirely. It was the mountain breathing. Word of the discovery quickly reached Dr. Glenn Williams-Jones, a professor of volcanology at Simon Fraser University. By August, he and his colleague, Dr. Kelly Russell from the University of British Columbia, were in a helicopter of their own, flying directly toward the glacier. What they found was a clear signal of unrest. The vents were fumaroles, openings in the Earth's crust emitting steam and volcanic gases from a shallow magmatic source. As their instruments took readings from a safe distance, the data confirmed their fears. Lethal concentrations of hydrogen sulfide and carbon dioxide were billowing out from beneath the ice. The mountain was not dormant. It was quiescent, resting, but very much alive, a fact that was now melting its way through solid ice in holes 30 meters wide. It's a strange thing to think about, a mountain falling apart from the inside. Curious what you think about that, actually. But here's the detail that tells the real story. The gas itself was not the primary threat. It was a symptom of the true danger. For decades, geologists have known that Mount Meager is, in the words of Dr. Williams-Jones, a rotten mountain. Unlike the solid granite of its neighboring peaks in the Coast Mountains, Meager is a composite of fractured lava flows, ash, and pyroclastic rock. For thousands of years, superheated acidic water and gases from the volcano's plumbing system have been percolating through these layers. This process, called hydrothermal alteration, fundamentally changes the rock. It breaks down hard, stable minerals and transforms them into soft, weak clay. The entire edifice from its core outwards is being chemically degraded. It is losing its structural integrity. For millennia, this internal weakness was managed by one critical external force: the immense weight and pressure of the glaciers encasing the mountain. The ice acted as a structural buttress, a frozen brace holding the crumbling peaks in place. Now, that brace is melting. As global temperatures rise, the glaciers are thinning and retreating at an accelerating rate. With every meter of ice that disappears, the confining pressure on the hydrothermally altered rock is reduced. The rotten mountain is being exposed. This is the part of the story the disaster movies get wrong. The most immediate threat from Mount Meager is not a pillar of ash rising into the stratosphere. It is a landslide of a scale almost too large to comprehend. Zoom out, and the history makes the mechanism terrifyingly clear. At 3:27 in the morning, on August 6, 2010, the south face of one of Meager's secondary peaks simply collapsed. Without an earthquake, without an eruption, an enormous mass of weakened rock gave way. Between 45 and 53 million cubic meters of debris, enough to fill a major sports stadium, 20 times over, crushed down into the valley below. The landslide traveled at over 30 meters per second, nearly 110 kilometers per hour. It obliterated the confluence of Meager Creek and Capricorn Creek, creating a dam that temporarily blocked the river and sent a surge of water and wood debris downstream, destroying bridges and logging infrastructure. There were no fatalities, but only because it happened in the dead of night, in a valley that was, at that moment, empty. The event was so violent it registered on seismometers as far away as Alaska and Washington state, over 2,000 kilometers distant. At the time, it was logged as the largest landslide in all of Canadian history. Now, here is the part nobody was prepared for. That 2010 collapse was not the main event. It was a warning shot. In the years since, satellite radar technology known as INSAR has allowed scientists at the Center for Natural Hazards Research to monitor the mountain's surface with millimeter precision. The data shows that other, larger sections of the massif are not only unstable, but are actively deforming. They are moving several centimeters a month. The very slopes that loom over the path of the 2010 slide are slumping, getting ready for the next failure. And because of the continued glacial melt, the next event could be an order of magnitude larger. The 2010 slide was a catastrophic event, but it was a failure of just one part of a secondary peak. The entire western and southern flanks of the main volcanic edifice, the parts directly weakened by the newly discovered fumaroles, are now being watched. The cycle is accelerating. A catastrophic failure is no longer a question of if, it is a matter of when. This is the kind of geological story we follow here. You can subscribe if you want more videos like this. The path of that future disaster is brutally straightforward. A large-scale collapse would funnel directly into the Lillooet River Valley. It would almost certainly generate a lahar, a fast-moving slurry of rock, mud, and water, with the consistency of wet concrete. That lahar would travel downstream following the river's course. And just 65 kilometers down that valley lies the town of Pemberton. With a regional population of several thousand, Pemberton is situated directly in the primary hazard zone. An outburst flood from a landslide-dammed river, or a direct lahar impact, could reach the town in a matter of hours, or even less. The infrastructure, the homes, the lives in the Pemberton Valley, are all downstream from a volcano that is known to be structurally failing. This isn't speculation. In 2024, Natural Resources Canada, the government agency responsible for monitoring these threats, published a new threat assessment. Using the same methodology as the U.S. Geological Survey, they analyzed all of Canada's volcanoes. Mount Meager, along with nearby Mount Garibaldi, received the highest possible threat score, very high. It was an official recognition of the dual dangers, the massive landslide potential and the underlying explosive risk. The report confirmed that Meager poses a significant and direct threat to people, property, and critical infrastructure. The sleepy giant in British Columbia's backcountry was now officially on record as Canada's deadliest volcanic threat. And this brings us to the second, more primal fear. A collapse is the most probable threat, but it is not the only one. The fumaroles discovered in 2016 are an unambiguous sign of an active magmatic system. The volcano has erupted before, and it has done so with extraordinary violence. The last major event occurred approximately 2,400 years ago, around 410 BCE. An explosive eruption from a crater known as the Bridge River Vent blasted rock and ash with a force that rivaled the 1980 eruption of Mount St. Helens. It registered as a 4 or 5 on the Volcanic Explosivity Index, making it the largest Holocene eruption in Canada by a significant margin. Pyroclastic flows, incinerating clouds of gas and rock moving at hundreds of kilometers per hour, roared down the mountain's flanks and slammed into the Lillooet River. The flows were so immense, they created a debris dam over 100 meters high, completely blocking the river and forming a large temporary lake. Ash from this single event has been found as far away as central Alberta. But the eruption was only the first part of the disaster. That natural dam, composed of loose volcanic debris, was inherently unstable. Eventually, whether in a matter of days or weeks, it failed. The catastrophic outburst flood that followed sent a wall of water, mud, and rock scouring the entire Lillooet River Valley, wiping the landscape clean for dozens of kilometers downstream. Every tree, every animal, every trace of the valley floor as it had been was erased. For decades, geologists worked to piece this sequence of events together, mapping the ash deposits and the ancient floodplains. They were confirming a story that someone else had already recorded. The Lillooet Nation, an indigenous people whose traditional territory encompasses the region, have an oral tradition known as the story of the copper canoe. The story describes a time when the mountain now called Meager exploded, raining ash down on the land. It speaks of a great blockage of the river, and then a devastating flood that destroyed their villages. For 2.5 millennia, passed down from generation to generation, the Lillooet people preserved a perfect eyewitness geological record of the eruption, the damming, and the outburst flood. It is a story of survival and resilience in the face of a power that can remake the world in an afternoon. That story is a reminder that this is not a new threat. It is an ancient one, simply biding its time. It's a history worth sharing, and a low-key like on the video helps more people discover this powerful connection between geology and oral tradition. The scientific investigation into the mountain's current restlessness has only intensified. The discovery of the fumaroles in 2016 triggered a new wave of research. Dr. Williams-Jones and his team returned to the site, analyzing the chemistry of the gases for clues about the state of the magma below. Changes in the ratio of gases like carbon dioxide, sulfur dioxide, and hydrogen sulfide can indicate whether fresh magma is rising towards the surface. But getting those samples is extraordinarily dangerous. In 2022, a team led by Canadian cave explorer Christian Stenner, funded by the Trebek Initiative, undertook a mission that seems pulled from science fiction. They rappelled directly into the ice caves that the fumaroles had melted into the Job Glacier. The environment inside was like another world. Pitch black, filled with the roar of venting gas, and dripping with sulfuric acid that ate through fabric and metal. The primary danger, however, was invisible. The hydrogen sulfide gas venting from the mountain floor is heavier than air. It pools in low-lying areas, creating unseen death traps. To fall into one of these caves, or even to stumble in a depression on the cave floor, would mean instant suffocation. The air is toxic enough to kill in a single breath. Wearing full-face respirators and carrying an array of gas monitors, Stenner's team carefully descended into this subterranean labyrinth. Their goal was to collect uncontaminated gas samples directly from the source and to sample the unique extremophile bacteria that were thriving in this toxic acidic environment. The mission was a success. They were able to confirm the volcanic origin of the gases and provide crucial baseline data for monitoring any future changes. Their descent into the belly of the beast proved, beyond any doubt, that the heat source driving these vents is real, shallow, and active. This leads to the most unsettling part of Canada's volcanic situation. The 2024 threat assessment that ranked Mount Meager as very high came with a chilling addendum. The report stated that no Canadian volcano currently meets the international standard for adequate monitoring. Unlike Mount St. Helens or Mount Rainier in the United States, which are covered in a dense network of seismometers, GPS stations, and gas sensors designed to give weeks or months of warning before an eruption, Mount Meager is comparatively blind. Natural Resources Canada maintains a regional network of seismometers, but the volcano itself lacks a dedicated, modern, real-time monitoring array on its own slopes. As Dr. Melanie Kelman, a volcanologist with the Geological Survey of Canada and a co-author of the report, has noted, "We simply don't know what the mountain's normal background level of activity is. We cannot, therefore, reliably detect the subtle changes that would signal an imminent eruption or a large-scale collapse." The warning time for the people living in Pemberton and the surrounding valleys could be drastically shorter than for those living near a well-monitored U.S. volcano. We saw the vents in 2016 by pure chance, because of a goat survey. What else are we not seeing? The report was not just a scientific classification. It was a wake-up call. Canada is home to the northernmost extension of the same volcanic arc that threatens the U.S. Pacific Northwest. Yet the level of preparedness is worlds apart. Dr. Kelman's assessment is stark and clear. Meager could erupt in 10 years, 50 years, or 3,000 years. We simply do not have the data to know. The problem is compounded by the mountain's own character. Meager is not a simple conical stratovolcano. It is a massif, a complex of multiple overlapping volcanic vents and edifices built up over 2 million years. Its highest point, Plinth Peak, is the remnant of one of these vent structures. The Bridge River Vent, source of the cataclysmic eruption 2,400 years ago, is another. This complex geology makes it incredibly difficult to model and predict. An eruption might not come from the main peak, but from a new vent bursting through a weakened flank. A collapse might not be a single event, but a series of failures across the entire rotten complex. Imagine a building whose foundation is cracked, whose support beams are rotting, and whose plumbing is leaking corrosive fluid, all while sitting in an earthquake zone. That is Mount Meager. And the earthquake in this analogy is not just a tectonic shift, it is the steady, inexorable force of climate change, removing the external support that has kept the decaying structure standing. Each summer, as the glacial ice line creeps higher up the mountain, the probability of failure increases. The mountain is being attacked from within by its own heat, and from without by a warming climate. This dual threat is what makes it so uniquely dangerous. It doesn't need to choose its method of destruction. It has two, and they are working in concert. So, the people of the Lillooet Valley live with this knowledge. They live in a landscape shaped by the volcano's last great act, in the path of its next one. The scientific community, People like Dr. Williams-Jones, Dr. Russell, and Dr. Kellman continue to push for better monitoring, stretching limited budgets to gather whatever data they can from satellites and infrequent field visits. They are trying to listen to a mountain that has proven it can go from silence to cataclysm with very little warning. The 2010 landslide was described by Dr. Williams-Jones as a biblical-level event, an unzipping of solid rock that defied our modern view of slow, steady geological change. It was a reminder that the Earth does not always operate on human timescales. It can, and does, produce events of almost unimaginable speed and force. That single non-eruptive event cost an estimated $10 million in damages to infrastructure. A full-scale eruption, or a truly massive collapse, impacting Pemberton, would have a cost that is impossible to calculate, measured not just in dollars, but in lives. For now, the mountain sits quiet, steaming gently under its mantle of ice. The tourists who come to the region to ski, hike, and fish see a majestic peak, part of the stunning backdrop of the coast mountains. They do not see the internal decay, the deforming slopes, or the toxic caverns hidden beneath the glaciers. They see a mountain, not a slowly unfolding disaster. There is one more thing the data does not yet answer. How close is the magmatic system to the surface? The fumaroles confirm it is active, but the depth and volume of the magma chamber beneath Meager remain largely unmapped. Is it a small cooling body of rock, or a large recharging system preparing for its next cycle? Without the kind of deep seismic imaging done at other high-threat volcanoes, this remains the most critical unknown. The answer determines whether the next event will be another landslide or something far, far worse. So, 3 questions hang over the massif tonight. How long will the melting glaciers be able to hold back the rotten, unstable rock of the mountain's flanks? Will the first true warning of the next cataclysm come from the subtle tremors of rising magma, or the sudden, silent failure of a mountainside? And what does it mean for a nation to harbor a very high-threat volcano, one capable of a St. Helens-style eruption, and a historic landslide without a comprehensive, dedicated system to watch its every move? The acidic fluids are right now deep inside the mountain, turning solid rock into clay, molecule by molecule. The meltwater from the Job Glacier is seeping into fractures, lubricating the paths of future failure. And somewhere deep beneath the fractured rock and steaming vents, a body of magma is waiting. The pressure is building. The mountain is unzipping, and the next chapter in its 2-million-year history is on its way to the surface. Most people forget to subscribe after watching this far, so there's your reminder.